Titration of weak acid against a strong base. There is calculation of pH at the different stages. Now today we are discuss at the equivalence point. 10 cm cube of NaOH has been added to acetic acid solution. The acid is completely neutralized. Only completely neutral. Only salt will be present, and its concentration is therefore the concentration of salt is equal to 10 cm cube having concentration 0.1 molar. The total volume, that is, these are the 10 cm cube and already present 10 cm cube, therefore 20. Now the concentration of salt will be 0.05 molar. Therefore the pH at the equivalence point will correspond to that of the sodium acetate. In this case, the concentration of sodium acetate is 0.05 molar. For this purpose, consider the hydrolysis of sodium acetate, that is, hydrolysis of sodium acetate. Now CH3 COONA is reacted in presence of H2O, formation of acetic acid like CH3 COOH plus NaOH. Now the acetate ion like CH3 CO minus ion reacted in presence of H2O. This is again a reversible reaction to form acetic acid plus OH minus ions. Now the hydrolysis constant, that is KH, can be defined as hydrolysis constant KH, hydrolysis constant will be, that is, KH is equal to the concentration of acetic acid CH3COH into concentration of OH minus ions divided by concentration of CH3COO minus ions. In the solution, there will also be two more equilibria, namely the first one, dissociation of weak acid, dissociation of weak acid like the CH3COH, which can dissociate to form CH3CO minus plus H plus ion. Now the dissociation constant for this acid, that is Ka, will be concentration of CH3CO minus into concentration of H plus ion divided by concentration of CH3COOH. The second equilibria, the dissociation of water, dissociation of H2O, that is water, which can dissociate to form H plus ions plus OH minus ions. Now the ionic product of water is equal to concentration of H plus ions into concentration of OH minus ions, where Kw is ionic product of the waters, that is, these are the ionic product of the water. Now dividing the equation above two equations, that is the Kw divided into Ka is equal to the concentration of H plus ion into concentration of OH minus ion divided by concentration of acetate ion into concentration of H plus ions into concentration of CH3COH, which can simplify like the concentration of CH3COOH into concentration of OH minus ion divided by the concentration of CH3CO minus ions, which is identical with above equation. Therefore the Kw upon Ka is equal to Kh, or it also known as, that is, Kh is equal to Kw upon Ka. Here H is represent the hydrolysis constant, H hydrolysis, that is fraction of the total number of mole of salt that has undergone hydrolysis at equilibrium, and C is the molar concentration of the salt. Then at the equilibrium, the concentration of CH3CO minus acetate ion is equal to, at equilibrium the concentration of CH3CO minus will be 1 minus H C, and the concentration of CH3COH is equal to concentration of OH minus will be EHC. Therefore the KH is equal to EHC into EHC divided by 1 minus H into C. Here the concentration, that is C, will get cancelled. Now there is a hydrolysis constant H square C. If the 1 minus H is equal to or less than 1, that is very small, therefore the H is equal to under root KH upon C, since the concentration of OH minus ions will equal to HC is equal to under root KH upon C into C. Therefore the under root KH into C. Now the KH is equal to KW upon Ka, and concentration of OH is equal to under root Kw upon Ka into C. Therefore the concentration of H plus ion is equal to Kw upon concentration of OH minus ions will equal to Kw upon under root the concentration of Kw into divided by Ka into C. Therefore it will get the under root Kw into Ka divided by C. Taking the logarithm and simplifying this equation, taking log of and simplifying, now pH is equal to half in bracket pKw plus pKa plus log C. In this case the pKa is equal to minus log to the base 10, Ka is equal to minus log base 10 1.8 into 10 raised to minus 5 is equal to 4.74, and the C will be 0.05 molar, and Kw is equal to 10 raised to minus 14. Therefore the pH is equal to half into 14 plus half into 4.74 plus half into log to the base 10 the concentration 0.8 0.05, it will get 8.72. Now the pH at the equivalence point of the addition of 10 cm cube of strong base, that is NaOH, into the weak acid, that is it will get pH 8.72 at equivalence point of titration. Now pH at the excessive addition, suppose when the 10.1 cm cube of NaOH has been added into the solution of weak acid, the concentration of excess hydroxyl ion, that is 0.1 cm cube of NaOH, will be excess, and the total volume of the solution, that is 20.1 cm cube in the conical flask. Therefore the concentration of excess base and hence hydroxyl ion will be concentration of excess base, that is 0.1 cm cube, and hydroxyl ion will be here the concentration of OH minus ion is equal to concentration of NaOH is equal to the excessive addition, that is 0.1 cm cube having concentration 0.1 divided by the total volume, that is 20.1, it will get the concentration, that is 4.975 into 10 raised to minus 4. Therefore the POH is equal to minus log into concentration of OH minus ion will equal to minus log 4.975 into 10 raised to minus 4. It will get the 3.03, and the pH of the solution, the 14 minus 3.303, it will get the pH of the solution will be 10.7. Now you can calculate the pH of excessive addition of solution, that is one is 11.0 cm cube addition of NaOH and 12.0 cm cube of NaOH added into the weak acid solution. You can calculate for this both additions and then send the correct answer of this pH.